Okay, so now we're actually going to kind of tie together what we've done so far and apply that um, to finding the actual real zeros or those zeros for a polynomial function. Remember that the first step you should always do is the potential rational roots. You should always go and find these first and list those out just in case. And the first couple of homework problems actually make you do that. That's the first thing I ask for. But from there on out, what we really want to do is think about this little procedure right here. And step number one is just determine the maximum number of zeros. So when I look at this guy right here, the biggest exponent is 3. So I know that right now when I solve this problem, I should get done with it and I should have 3 zeros. And from those 3 zeros, I should have 1, 2, 3 factors that I should be able to find. Okay, so to do that, we can definitely list our potential rational zeros. We can do the P over Q thing like we did in the previous video, or we can just go right to our graphing technology. So we come to our calculator, we go to y equals. So once again, this is the one where if you're trying to go back through and figure out how to plug it all in, this is your first time seeing that from me. So we go ahead and type it in. We say 3. X is located up here next to the alpha key. Caret gives us an exponent, so caret third power plus 8x squared minus 7x minus 12. Okay, so remember we've already done zoom 6, but we can do it again. We can kind of get a visualization that it looks like it crosses at, right now it looks like -2, -1, +1. But let's go take a look at our table and see for sure. So now we go second graph. So sure enough, we have -3. So we have x equals -3. We have x equals -1. And then it looks like it happens somewhere between 1 and 2, but it's not exactly 1 or 2, so we got to leave that one blank. All right, so based upon this, we can go backwards. We realize that our factor would be x plus 3. Our factor would be x plus 1. And if you're like, whoa, how did he do that? Remember that, and I'm going to write this and then erase it. Remember that if I go the other way, if I took x plus 3 and set it equal to 0, then I would subtract 3, and I would get x is equal to -3. Well, we're going the other way around, so now we already have our 0, and we're going back to our factor, so we know it's going to be opposite. So hit rewind if you need to on that, and think about that for a moment. But now we come down to this idea that, well, the whole reason we've been using synthetic division or learning synthetic division was because we wanted to be able to plug this in and be able to find all of our possible zeros or all of our possible factors. So our first 0 that we had was -3. So I'm going to use, I use an upside down division sign when I do synthetic division, so I put it like that, but I still put the factors in. So I've got my 3, I've got my 8, I've got my -7, and I've got my -12. I still have my spot for my remainder. So it's just upside down, and I do that because it's a visual differentiation for me. So I know it's not long division. I know it's synthetic division. I bring down my first number. I get 3. 3 times -3 times +3 is -9. I add, I get -1. A negative times a negative is a positive. I add, I get -4. A negative times a negative is a positive. I add, I get 0. So at this point, I know that I have 3x squared minus 1x minus 4. Because I started off with an x cube, I divided 1 degree out of it, and now I'm down to an x squared. So that confirms that this one works, that -3 works because I got a remainder of 0. So now from there, I take my -1 and I divide it into my new polynomial. So into this guy, I bring him up over here. So he's 3, -1, -4. Create a spot for my remainder. Bring down my first term. So a negative times a positive is a negative. I add, I get -4. A negative times a negative is a positive. I add, I get 0. I'm 1 degree less now, so I was x squared. So now I started with x cubed. I divided out once, I got x squared. I divided out again, I took me down to 3x minus 4. So that's my last factor. Like, that is the answer that goes right there. That's my last factor. So my job is to take that factor and make it into a 0. Remember, you take your factor, you set it equal to 0. So we add 4, we add 4. So I get 3x is equal to 4. I divide by 3, I divide by 3, and I get x is equal to 4/3. So 4/3, if you remember on your calculator, we pull that back up and we take a look at it. Just to remind us, 4 divided by 3 is 1.3333. So let's see if we go to our graph and look at that. Oh, that would make sense because it's right past 1 and in between 1 and 2. So 1.33 would be a good number. So that's how we take, that's how we take our polynomials, use our technology. Remember, our procedure is to kind of use our technology to say, well, what are the possible, or what are the roots that we know work? Take the ones that we know work and use synthetic division to divide it out until you can get all of your zeros and all of your factors. Alright, so that should get you through several of the other homework problems. The other thing, and just kind of touch on it all here at one time, is that the other part of the homework is just talking about, like, if I give you zeros, then you can go to factors, or from factors to zeros. Alright,